Good afternoon, students. Today we are going to discuss about network function virtualization, or in general we call it NFV. This is somewhat related topic. With this, you can relate it with the previous topic that we discussed in last lecture, which was software-defined networking. Uh, they are similar terms and mean they are supporting each other, but they are different from each other in terms of functionality. Uh, Before going to discuss that, first let's see what are existing networks functions. uh, the main thing is you have to route that data. To protect that, you need to apply some encryption techniques for the security purposes. Then sometime some data you the network administrator want to allow, and sometime it depends. For example, you don't want to allow Facebook or any other social media services at the campus. So the thing you can do is just to use a firewall. Then the people use network address translator. Then the DNS server is used in order to assign the names against IP. Then DPI, BRAS, and various other servers are used for different purposes. So the question is, with the increasing network services and having $1 billion people will invest in the future. So whether it is feasible to have different components at customer premises for different network functions, the obvious answer should be if there is some that, because the vendors will be different. At the same time, the issue will be interoperability, scalability, and along of other issues that usually involve with different vendors. So why not have a single platform where we can, by using some software mechanism, those services, network services, can be provided using shared voltage, shared storage, shared network infrastructure, and at the same time shared processing infrastructure. You can have a platform where you can provide all those services, to which is called as virtual so network function, which is called as network function virtualization. Mean to virtualize those network functions in such a way that to the third to that the third party or the customer doesn't know, or he is not supposed to pay for extra equipment as well. So here these are at customer premises. These services can be provided in such a virtual environment where you can have virtual network devices such as switches. Similarly, storage can be provided, you don't know, in the form of cloud. Their services can be provided. Similarly, multiple servers, a single server will provide functionality of multiple services such as domain names, DNS server, NAT, BRAS, and firewall. Let's see what is going to happen in the future. IoT, Internet of Thing is getting popular. What we say that every electronic equipment will be able to connect with the through the internet with the rest of the world. It means that any electronic equipment in one part of the world can be connected in any other part of the world. As it is said that by after 2 years, or by 2022, 50 billion devices, IoT devices, will be connected, which is not a small number. If we say, when we use IP version 4, so the total IP available throughout the world is 2 power 32, which is just over 4 billion. So imagine that when 50 billion devices will be connected, what will be the, whether the existing infrastructure will support that? The obvious question will be straight away no. For that, you need to use the network function virtualization in software defined networking, so that in combination of those, in other words, if we use a very generalized term, we can say that by using a shared infrastructure in the form of storage, shared physical infrastructure in the form of storage, computing capabilities which can be shared, then network capabilities, if the physical infrastructure is combined in such a way that that virtual network functions, for example, routing, switching, firewall, DNS, these services can be provided through their shared resources, and that layer will be called as virtualization layer. Mean it will provide to the, because this on the customer at the service layer, or we call it at application layer. Normally if we use TCP IP or OSISM layer model, the customer, whether data owner, object user, IoT service broker, all they don't know about the lower, they just need the service. But how to provide that service? By using these network function virtualization and SDN, you will have these type of, like, one, you will have virtualization layer. On top of that, you will have global operating system layer, where they will be operated globally by using hypervisors. And when we use SDN, we will use SDN controller, which decouple the data plane from control plane. So by doing that, there can be such a centralized system where the individual device will not be controlled distributedly, but rather centralizedly that can be controlled, and whose advantage will be that best route for routing can be find out in such a way. And on top of that, you will have service layer. So that is how you see there here we say virtual machine instead of physical machine. You are already aware of virtual machine. VMware maybe you have used, so which provide, there is no separate machine, but on top of your existing machine, another functionality is provided. For example, if you want to install Linux, you want to have a Linux environment on your Windows environment, so what you do, you install VMware, and where there that functionality, and physically the system remains same. So the same analogy can be used here, where you will have one on single machine, single server, you can be providing virtual network functions in the form of firewall, in the form of encryption, in the form of DNS, or any other physical network services that can be provided through different device, can now be provided on a single system using software mechanism, or in other words virtualization, that we can perform over here. So as I said earlier, this concept is based on the use of commercial off the shelf or COTS hardware for general purpose compute, storage, and network. Means that this hardware can be used for multiple network function, and those software function is necessary for running the network are now decoupled from the hardware. So just like the idea of SDN, that hardware or data plane and control plane is decoupled, in network function virtualization or NFV, the hardware network services are decoupled from the hardware. Mean it is not dependent that this a single hardware can provide the virtual functions in the form of switching, in the form of routing, in the form of encryption, in the form of firewall, and many other network functions. Now, up till now, what we discussed, there are the thing between SDN and NFV may not be clear to you, but it's these are two supporting terms, but totally they complement each other, but the services are different. For example, as we said earlier in the last lecture, SDN is basically software-defined networking, whose main job is to go from distribution services to centralized service, where you have centralized SDN controller, and whose job is to decouple the data plane from the control plane. So the just instead of taking decision at the same time, decision is taken somewhere else for quick processing. While NFV, it seeks to abstract network forwarding and other network function from the hardware. Mean it decouple the network function from the hardware. So when SDN execute on an NFV infrastructure, SDN forwards data packets from one network device to another network device. To make it more clear, I would like to show you a video on YouTube where you can see here.
In this video, I'm going to create this ebook in
the
just
difference
2 minutes.
between them and how it is used in the network environment. So let's see.
Our users connect to each other and to different services by using communication networks. Large and complex infrastructure continuously evolving that are made up of multiple nodes, components, and links. A network has a strong dependence on hardware, that's to say, on the physical equipment. This characteristic makes it a very rigid and expensive infrastructure to operate. Making changes to it, to evolve or to make the launch of new products and services possible, often involves long periods of time. The inclusion of new functionalities is delayed by the need for economies of scale in order to manufacture the specific network hardware, as well as by the long standardization processes between the vendors and operators. What's more, the very complexity of the network makes it hard to introduce changes from the perspectives of management, configuration, and control. In this situation, we need to transform the network to make it a much more flexible, nimble, and moldable infrastructure. The network must be able to adapt in a better way to the quick pace imposed by the evolution of the digital world. To that end, we have network virtualization as a significant lever for transformation. Network virtualization is composed of two technologies, NFV and SDN. Virtualizing the network consists of separating software from hardware and network equipment so that network functionalities become independent of the physical equipment supporting them. As all functionalities are found in software and not in the physical machines, the same server can be used for several purposes depending on the software installed on it. As functionalities reside exclusively in software, it is possible to package each network function in one or more virtual machines and to decide where to execute them. This is what's known as Network Function Virtualization, or NFV. This new concept is now feasible because a set of advances in general-purpose servers has managed to increase by an order of magnitude the performance that software can achieve in the handling of data. These advances have turned commercial off-the-shelf servers into the ideal candidate for network virtualization, owing to the significant economies of scale they represent. This is not a trivial process. Hardware resources must be allocated with great care in order to achieve high and predictable performance so that virtualized network functions can work at the same speed as traditional network functions. At the same time, those network functions must be interconnected with each other in a coherent way in order to provide network services. These interconnections can be managed from a centralized point. The centralization of the control plane is what is known as software-defined networks, or SDN. And what advantages does this new concept bring? It will be possible to install various network nodes on the same infrastructure, so it will be possible to share capacity among them. Thus, when there is a change in demand, instead of purchasing new network nodes, we can change the software to balance the capacity according to needs in a dynamic way. At the same time, from the point of view of management and investment, virtualized network functions will be more efficient than traditional ones. As this technology is gradually installed, the network will become a moldable infrastructure in which it will be possible to deploy functions on demand quickly and efficiently. The installation and configuration will be carried out in a more automatic way, making the process more economical while also making the network more resilient and simplifying the management of the functions already installed. The traditional and virtualized network worlds will have to live together during this process, so the transformation can be carried out gradually to support the flexibility and scalability that the telecommunications infrastructure of the future requires.
Okay, so student, I hope now you can differentiate and can see how network function virtualization and software defined network complement each other. So considering the economy of scale that we can see in the future, so these are the technologies of the future where hardware will be not of much importance, and importance will be given to software system that is developed. So it is depend on the software that is developed. Most probably it will be open source software will be used where it can be changed as per need, as per requirement, because for again for proprietary software the problem is you cannot make changes according to your wish. But whenever it is open source, that will prevail, where more and more services, network service, network function can be included in a single software, and that software which we will be later on using as a virtual machine, that will be using to perform different network services or network function by using a single hardware system. So to summarize, here we see that as we said, NFV stand for Network Function Virtualization. It is an innovative way to design, deploy, and manage network services whose job is to decouple network services from the physical hardware application so that it can run on software, right? So why, now the question, obviously you may ask this question, that why we need NFV if we have already network infrastructure available in the form of telecom infrastructure and various other networking infrastructure that is being deployed in different part of the world. The problem will be in future, the traffic will be so much that those hardware infrastructure may not support all the services. So to use existing infrastructure, and on top of that we use software mechanism where we in such a way that if more services are need to be incorporated, network services, network function, and the infrastructure, you don't need to change hardware infrastructure, just install it. Depends on the capability of the software and what features that are included, what network features that can be achieved. So it will definitely reduce your capex or capital expenses. Capital expenditure will be reduced, and at the same time operational expenditure or operational expenses will be coax and opex will be reduced. Similarly, speed will be up, it will grow, market will grow, speed will grow. At the same time more agility and flexibility will be included into the network. Now let's move toward the second part, or something that we discussed last time, which is called as software defined network. It is clear that the job of software defined network is now to decouple, to separate network control and forwarding plane or data plane to make it easier to optimize each other. Think about the SDN controller as a brain whose job is to control all the body function using neurons, right? So same is used, the idea is used in the SDN in the form of centralized controller or SDN controller. Why we need SDN? Again, same advantages. We will reduce the overall infrastructure cost, infrastructure expenses, operational expenses, right? Capital in or infrastructure expenses. It will provide more agility to the network and at the same time provide more flexibility. Now let's see deep into the network function virtualization architecture. So these are the main parts of the NFV, where you see uh, NFVI, which we call that as network function virtualization infrastructure, right? So on top of that, you will see combination of both SDN and NFV components will be working together as a team, because without SDN, we will not achieve the purpose of NFV. This PNF is called as physical network functions, where you have all those physical routers, switches, firewalls, etc. While VNF is virtual network function, right? So these are in combination working. You see, they are working in tandem with all the, and they are controlled through SDN. Means that different services, who is going to, at the end of the day, different services can be provided using shared storage, network and processing capabilities. But the thing is, who will be responsible, who will be able to control that? So SDN controller will basically do that job. At the end we will see what we mean by end-to-end orchestration, or in other words automation, that is provided, how that the virtual machine will behave as an independent NFV, a VNF, virtual network function, how it will perform that VNF. So that is will be through end-to-end orchestration or automation, right? Then you have, we call that as E2E in these like element management system, how you different network elements are being managed, operation service support and business service support. Those who work in telecom, they know that how you connect the operation with the businesses that you gain or from different customers, right? So how you gel them, how at the end, how you provide that services to the end customer. This is through network management you do, and for that you need to have different managers, agents who used to perform different function, like WIM manager, or we call it virtualized infrastructure manager, whose job is to connect with NFVO, VNFM, and by VNFM mean virtual network function manager, whose job is to manage that network, virtual network functions, right, in the form of routing, forwarding, encryption, providing security, providing quick processing of data. So that will be performed through VNFM. Similarly, we use time to time we will use different terms, and we will explain one by one. So as in infrastructure architecture framework, you see data center is, so there will be different, you have to, what we say SDN controllers, it means there will not be a single controller for data center. I mean, to manage the data, for that the SDN controller, in separate controller will be used, which is called as SDN controller. Then wide area networking, like you use the trunk network or the access network, where you need to have a physical infrastructure, maybe in the form of physical media like fiber optics, and they are installed so that the communication is wide area and networking is performed there. So for that, for WAN functionality, you need to install WAN SDN controller. Similarly, access SDN controller. Similarly, domain vendor specific controller, right? So these are different. So that's why we use the term controller. So there are different controllers used, and all of them will have the functionality of SDN, which means that that controller job will be to decouple the data plane from the control plane. All right, so that there is quick processing, there is no hurdle, there is no interoperability issues, right? Similarly, service orchestration, which means providing how the automation is provided in the service. Then different portals will be used. How different element like EMS, we say that, which if you see here, this is also connected. End of the day, you have to provide operational and business service support to the customer, right? So that can be done through EMS by using that physical network functions, right? But you have to go through that SDN controllers in order to provide that service. This is Mono, we call it Operation Support OSS and BSS, which is Operation Support System and Business Support System. Sorry, it was not services, but rather it's called a system, right? So architecture and further, uh, when we go in detail of NFV infrastructure, mean network function virtualization infrastructure, we say that it comprises all hardware and software components building up the environment in which virtual network functions, as I said earlier, that can be routing, that can be switching, that can be activities like DNS. What is the job of DNS? We know that in networking, NAT functionality, BRAS, at the same time, encryption or security services. These are all basically network functions. So that will be managed, deployed, and executed. Right? It includes hardware resources, virtualization layer, and virtualized resources like CPU, chipset, forwarding box. We can call that as router or layer 3 switch and their associated interfaces, because without interfaces these devices cannot perform functions in a coherent way. So this is how you can see that how they are connected with each other. Like you have this hardware resources in the form of computing resources, in the form of storage, in the form of networking, and we call that compute and storage as compute domain, while network part of hardware resources is called as while along with, as we said, along with those interfaces, which is virtualization infrastructure manager, VIM. We previously said the job of this manager is to provide virtualization using the existing hardware resources, right? So this is called as infrastructure networking domain, while the VM or virtual machine services are provided using virtualization layer. So in total we have three domain: virtualization domain, computing domain, and infrastructure networking domain. That we said, like computer domain includes compute and storage resources, while virtualization includes virtualization layer for virtual machine and containers that abstract the hardware resources, right? And third is infrastructure networking domain, whose job is, as we said earlier, this is infrastructure networking domain to connect hardware resources with the virtualization layer using virtualization infrastructure manager or VIM. This is how it looks like now. You will have this NFV node, which will be having hardware resources, computing resources, as well as storage resources. You have these computing hardware, storage hardware, and along with that, by NIC mean network interface card. So you physically you will have some hardware which will provide, because after all you have to connect it physically, but by this overall it will be called as we said, compute domain. This one will be called as network infrastructure network domain. This is hypervisor domain, or we call that as virtualization layer or virtualization domain, where you will instead of in physically, the every hardware has different physical equipment, but here they just like in cloud computing, you don't know where the physical servers are located, right? But at the end of the day, they provide you different kind of services in the form of data storage, in the form of various other services, right? Similarly, here your hardware resources may be combinedly used by using software, by using virtual machine in the form of virtual computing, virtual storage, and virtual networking. So overall, we will call that as by using all these services in conjunction in support. And for that you need, it depends, again I would say that it depends on the functionality of the software that it is capable to provide all those services, right? So we call that as virtual network function, right? So these virtual network functions can be provided irrespective. The more your requirement increase, the more capability you will include in your software, and the hardware capability will not be changed. So NFV domains, it depends on mainstream physical and virtual switches, like the switches that you used physically. But to enable that, you will use a virtual switch you call as V switch, and that you can achieve that by using different software. At the end, we will be discussing that. Okay, so as I said, we have different managers. We already discussed Vim, Virtualization Infrastructure Manager. This is VNF, Virtualization Network Function Manager. Mean that the manager whose job will be to manage those VNF services, or that virtualized network function services that will be managed, whose role will be uh, like VNF manager is an entity that is part of the NFV infrastructure framework defined by European Telecommunication Standard Infrastructure NFV that interact with the, so his job will be to interact with virtualization infrastructure manager, so that it can use the job of as we said earlier, VIM is our virtualization infrastructure manager, is to use the physical network resources, and that to provide in such a virtualized manner that it can be used for multiple virtualization network functions, right? Not just one. There's the network function can be used for firewall, at the same time routing, switching, so multiple VNF services, and that who will manage that? A VNF manager will manage that. So we discussed that already. VNF descriptors. So what is VNF descriptors? The job is we have network function virtualization infrastructure, which consists of physical network function PNF and virtualized network function VNF, right? So, and it also connect with OSS and BSS through EMS, right? Element management system, and that is connected, and you in between you also use different SDN controllers. That can be WAN SDN controller, that can be access SDN controller, right? Whose job is to decouple control plane from data plane, and at the same time have overall controls on the different functionality of the network. So VNF basically NFVI it is, and the NFVI intercomponent communication is exposed and supported by NFVI. Therefore, the intra VNF virtual link must be defined as part of the. So we discussed that earlier. Okay. We discussed this as well. So let's see how it works in the network environment. We say that this is VIM, our virtualization infrastructure manager, will coordinate with virtualization network function manager, and through that different repositories are used, different libraries are used, so that those are predefined, and it works through different engines, like and which is based can be based on policy management, configuration management, inventory, like what are different components are available, then network topology, which kind of topology can be used, so those are available in different repositories, right? And then workflow, if you can remember, it is we discussed that workflow, and we will be discussing in a while. It's a protocol which provide an interface, southbound interface between data plane and control plane and SDN. So we will see in a while what is the job of again in SDN. We discussed overflow already, but in VNF we will see how overflow works. Uh, E2EO are end-to-end orchestration. As I said earlier, EO is responsible for life cycle management of end-to-end network services. In fact, the automation is provided in the network and the NFV environment through end-to-end orchestration. It basically manages end-to-end network services that include connectivity through the network infrastructure outside the data center, which typically consists of PNF, which by PNF we mean not the virtual one, the physical network functions, which can be routing, switching, firewall, etc. So it EEO allocate resources, trigger instantiation of ENF, and configure network function in order to activate the end-to-end services. So its key job is, if we say its key function will be resource allocation and orchestration, execution of workflow, and at the same time topology and inventory management and configuration activation. You see that in previously here that his main job is, as we say, end-to-end orchestration. Main job is managing workflow, managing topology, inventory, configuration, and policy. Now let's see different SDN controller framework. As we said earlier, that the goal of SDN is to separate the management and control planes from the data plane networking function themselves, right? So, after all, we have to provide that services, also an operation system support a system, and that can be done like if you want to connect at the end of the day, you have to use some APIs to connect different applications with that, which will be with the management plane and at the same time control and data plane. So on top of that, you provide service R where different applications are used. So one of the job will be to manage and control that architecture by using a different SDN controllers. So SDN controller architecture is something like this. You have that end-to-end orchestration that will be managed through controllers like main SDN controller, whose job is based on controlling the software deploying networking functionality in wide area network. Then you have access SDN controller and various other controllers that can be used. Again, it will be working in coordination with virtual network function manager or VNF manager, and that is also will be to provide the network facility or to connect the virtualization layer with the NFVI or with the physical network functionality. So the Vim will provide those services, which Vim is basically virtualization infrastructure manager. So they are working in coordination with each other. So this is the SDN control. Basically, control across domain occurs in two forms. One is through the end-to-end orchestrator, and another one is through an SDN controller. So as we said, end-to-end. So there are two forms. One is through end-to-end orchestration, and one is through SDN. So you can see that in the figure here. This is the SDN. Just to recall that the framework previously we discussed, this was like network elements which can be switch, which can be router. So when SDN comes, so the router job is almost negligible. You can say that network element as switch. So they and then servers. This will be overall your infrastructure having different services and network elements that will be connected. So we call that as that will be data plane. So that will be decoupled in SDN from the control plane, means that you will have SDN controller where you will have different layer 2 or layer 3 modules that are GUI, cluster, various other layer 3 VPN module that can be connected by using open flow protocol, which is that interface is called southbound interface. So it decouples control, but to control plane is then managed or connected with the application layer, or by along with that you use management plane as well, right? And all of infrastructure layer, control and application layer, they all are managed through the management plane as well. But that northbound interface is then connected, like the service end of that, you have to provide that network services that can be in the form of network management app, in the form of load balancer, in the form of policy enforcement, in the form of bandwidth management, how to manage the network bandwidth, right? It can be, previously it could not be done centralized, how to manage the bandwidth, because if in a case there is congestion, through how to allocate the bandwidth, how to distribute the bandwidth, how to reroute the data from one route to another route. So now it can be done by using SDN plane. Now the idea is why we are going to discuss SDN here, because we need to provide to give you the idea about service abstraction layer here. Like both job is to provide abstraction, mean decouple. In NFV we decouple the network from the hardware, network function from the hardware. So here that is done by using service abstraction layer. Basically it is the heart of the modular design of the controller and allow it to support multiple protocols on the southbound. In SDN we use overflow in the southbound and provide consistent services for the module in different applications. So service abstraction layer or cell provide basic services like to discover the devices that are part of that infrastructure, used by modules like a topology manager to build the topology and device capabilities. So here you can see that how this different device are discovered, and then how it connected using different SDN controllers, and through which it provide connectivity for different services that are being given at the different network services that are being given at the upper layer, we call this application layer. So if those who have idea about programming, so these are the services that can be provided by using cell, which is I listen data packet, first listen, then once the packet is received provide service, then plug out and plug. So these are different. If you want to have, you can write a simple program for that, like whether you want which kind of service. Now let's see evolution of the controller of cell. So you can see here you have different any network elements, and once again network elements can be servers, can be routers, and that can be switches. So when they are connected using different repositories in the form of a library that can be in the form of configuration, different protocols, and border gateway protocols that are usually used to provide routing between different autonomous systems. So then they are through the abstraction layer. This is what the abstraction layer is. So the job of abstraction layer is to provide that virtualization by using virtual machines. On top of that physical infrastructure, you have different virtual machines, and that different virtual machine provide different VNF or virtual network functions. So there is another manager which we call a switch manager. The switch manager API holds the detail of the network element, that what actually that network element, what is, whether that is layer 3 switch or layer 2 switch. So as a network element is discovered, for example some router is discovered, it attributes are stored in the database by, so the job of switch manager will be to store that attribute in the database, so that the system knows that this network element is capable, it has that much capabilities. High availability. The open day, like this is one of the controller, supports a cluster based high availability model, so that to make controller highly available, what we have to do, we need to add resilience at controller level to make sure that OF enable switches. OF stand for open flow. Enable switches are multi-home. So what is open flow? We will discuss first hypervisor, and then after hypervisor we will discuss open flow. So now we said up till now, what, just to discuss hypervisor before we say that virtual machines are basically those software systems which provide which enable through Vim, connecting NFVI with Vim and then with VNF manager to provide that virtual machine or virtual network functions by using the shared network processing and storage resources, right? So who manages that? The question is again, so basically that is called a hypervisor or a virtual machine monitor, or VMM is basically a computer software, can be firmware or hardware, that creates and run virtual machine, right? So so basically the virtual machine is created through the hypervisor, right? And each virtual machine is called as the guest machine. So it will, guest machine is that it will be for a particular function, it will be created on existing machine, and once it is over, so it will not be required. That's why we call that as guest machines. There is a function which abstract, isolate operating system and application from the underlying computing hardware. As we said earlier, decouple the hardware from the network function from the hardware element. So it is called as VMM or virtual machine monitor as well. So it provides different benefits to enterprise the data service. So that is how it looks. You have the underlying infrastructure in the form of storage servers, and it's called hardware infrastructure. Through hypervisor you make that guest machines or virtual machines whose job is to have a separate OS for different applications. Like if you want to have a firewall, you want to block some data, you want to monitor some data, you want to allow some data, so that application will be different. So different using an OS, different virtual machine will be used. Similarly for routing, different VM will be used, and that will be provided by the hypervisor. So there are different type of hypervisor. Microsoft Hyper V, you can use VMware, you can use vSphere, vSphere, and Hyper-V. So two principal type of either are vSphere, Hyper-V, or VMware Player or parallel desktops applications. You can these are the two approaches. One is with used host operating system. For example, in VMware you use host operating system, means on top of host operating system, on top of Windows, you use that mechanism. So you need to have a host operating system, but sometimes you don't need, you have a different functionality like Hyper-V, where there you don't need a host operating system. In that case you use without host. So these are two principal approaches that you can use in order to provide a hypervisor in virtual network function virtualization. So we already use that hypervisor is used to any system administrator or system operator because it aids that virtualization or crucial layer of management and control over the data center in enterprise environment. So we already discussed this functionality of hypervisor. Now, as I said before, we will discuss OpenFlow. Though you may recall that we discussed this in SDN. So what is, why we want to include it here as well, let's see in a while. Just to recall that we said that OpenFlow enables software defined networking for programmable networks and is based on the Ethernet switch, which is an interflow table and standardized interface to add and remove entries. As we said, it provides an interface. I mean, it decouple the data plane from the control plane in the form that there is some so you have to keep in mind that this is a protocol basically which provides. So in protocol we say that when different packets data are used in from the fields, that we know that what different functionality it can provide. So two major component of overflow OpenFlow protocol is flow table. As you remember, we use matches, entries, and action, right? So, and secure channel protocol. So these are two components. One is secure channel through which that communication is provided. Our connection is established between controller and the infrastructure or data layer. And second is flow table. So what are the entries in the flow table? In flow table you have three basic entries: the header entries, you have action and counters. Like whenever each packet that enters a device is passed through one or more flow tables. So whenever it passes any packet which passes through any, so it has to go through that flow table. So what is inside that header? So in header field, each flow table header entry is made of 6 components. What are those components? These basically define the matching rules and basic rules for the corresponding flow. For example, if the packet is matched with the existing entry, so what if it is matched, so what next, whether you have to prioritize some packets, whether you have to discard it, whether you have to forward it. So that depends on these 6 components in the form of counters, instruction, timeout, cookies, and priorities. So what action need to be taken if the entries are matched? Each flow entry is associated with 0 or more action that dictates how the device handles matching packets. So either it drop or modify the field, or it can forward that particular packet. So we can say that the second part is, as we said, 2 components. One is flow entry, and the second flow table, and the second component of OpenFlow protocol is called as secure channel. So the OpenFlow protocol describes message exchanges that take place between the OpenFlow controller and OpenFlow device. It also supports 3 types of messages that can be controller to device. It can be asynchronous or it can be symmetric. Now let's discuss SDN WAN, software defined wide area network. Up till now, wide area network, how networking is performed, it depends on traditionally you use routing protocols that can be inter-domain routing and intra-domain routing, where a router, every time when a packet is reached, because two autonomous systems are connected or two networks are connected through the router, so that router has routing table, and the decision is based like what will be the next interface based on the destination address along with the subnet marks that are being used. So these are the entries in the routing table. So now what will happen if that your wide area network is on software based? So specifically it can be used to connections in broadband networking such as 4G, LTE, MPLS. You may recall we use the MPLS on top of ATM, and why we need to use MPLS to use labels whose domain was local, not global. So some for quick processing of data or datagram, we used to use assign labels, and on the basis of that, instead of make decision on basis of IP addresses. So again, let's come back to the software-defined wide area network. It relies on four central components, which is edge connectivity abstraction, WAN virtualization, policy-driven centralized management. Again, and that can be through using SDN controller, and then elastic traffic management. So that is how it looks like. You provide encrypted tunnels, and by tunnels, if you remember, when we were using IP6 in the option part of IP internet protocol, we use through functionalities. One is called as authentication header, and the other one was called as ESP. In ESP, where we provide encryption. So there were two mode of transport. One is tunnel mode, and another one was transport mode. In tunnel mode, in transport mode, only the payload is encrypted. The IP will remain safe, and forwarding will be based on the original IP. But in tunnel mode, what you do, the original IP is also that it is further encrypted. No one know in between that where that data is going to the destination. So this is can be done by doing through the software defined wide area network like this. So again, very obvious, if you want to bring flexibility, scalability, security, reliability, so for that you have to change your WAN on software basis, where no physical infrastructure need to be changed, no upgradation is required. The only upgradation every time will be to install some software on top of that hardware, whose job will be, who can work as a VNF, virtual network functions, and using that hypervisor through virtual machine, you can provide that software services on the virtual area network. So again, as I said, you need to have SDN in network function optimization, so that you can achieve WAN services using software defined networking. So these are different components that you can see. By doing so, you will be required these components in the form of or in other word, you have to install software that are software defined networking functionality by using that SDN controllers, and you can manage remotely and the network services, wide area network services, and that how it can be done using your existing infrastructure. And by when you want to provide security, you need to incorporate the tunneling functionality in the network. Finally, we are going to reach to the end. So customer premises equipment, or we call it CPE. So like in our house, we have CPEs in the form of those routers, that the point of access point. that we use in order to connect the network. So instead of that, in VNF, we use our NFV, network function virtualization, we use VCP. It is a way to deliver network services such as routing, firewall, security, and VPN connectivity to enterprises by using software rather than dedicated hardware device. So VCP, also known as Cloud CP, abstracts the intelligence of such device into software-based functionality that reside in a remote data center. Physically, it may be somewhere else, but it provides that functionality through software, that services, that the network functions, functionality like connect, routing, firewall, security, that all can be provided remotely. So the benefit is basically it is leading application to move hardware appliances functionality to software or in commercial platform. The way data centers behave or works. So the customer premises are natural fit for VCE deployment, meaning physically it will be somewhere else, but through software that functionality can be provided at the customer premises. So again, VCP benefits are obvious. Uh, for it is very convenient for service provider, instead of sending that some individual to go and check at the customer premises, that functionality can be remotely checked and service can be provided instead of going into the customer premises physically. So the ability to shop for best bread solutions, the freedom to customize service to specific customer needs. At the same time, it will definitely reduce the equipment cost, right? Finally, what is in the initial figure, maybe you have seen Mano. So Mano is basically, it is the NFV management and organization. Uh, Mano stands for management, NFV management and organization, whose job is the management of NFV. So when we say management, so it is like how to manage that virtualization. So the it is basically the ESI, or the European Telecommunication Standard Institute standard that define networks for management and orchestration of all resources at the cloud data center. So it manages how you connect NFVI through Vim, through NFV manager, and through virtualization infrastructure manager. So it is broken up into three functional blocks. One is called NFV orchestrator, VNF manager. So in combinedly, NFV orchestrator, Vim, VNF, and NFV orchestrator is called as their combined management is called as Mano. Alright, so we discussed that earlier. We don't need to go in that detail again. There are different computing platforms, Cisco ASI, Honors, or different. You can use it, Beacon, Jupyter, Contrail, POX, so different computing platform that can be used for SDN. And if you remember, last time we used multinet, mininet, and we will discuss that in the next lecture as well. Finally, we are concluding and we want to see what is VNF now, because everything is surrounding around VNF, virtual network functionality. So firewall, routing, switching, these, and that is not by using the physical. You can use a combined infrastructure, NFVI infrastructure, that have the capability of computing, processing, storing, and networking, and that by using the Mano in combination of Vim, virtualization infrastructure manager, VNF manager, you can provide that virtual services to the different different organization who are using different application for different purposes. So that is how it looks. With the combination of Bano, you can connect and by taking help from NFVI, which include both NP, NVP, both physical infrastructure as well as virtualized infrastructure or NFVI, that services can be provided. So students, let's conclude today's lecture. As in start we said that by an IoT environment you will have to connect billion of devices, so they will provide network services, and those network services can let alone the existing infrastructure. We cannot remove the existing infrastructure, it is really difficult. So you have to go to evolution, and instead of like completely discard those legacy devices, on top of that if we install software by using SDN and network NFV, we can provide those service. Instead of changing that, we can change the software, we can bring the capability in the system in such a way that that functionality can be incorporated, and at the same time connectivity, the network functions, which can be firewall, again switching, routing, security, and blah blah blah, that can be provided using the existing infrastructure, and at the same time provide scalability, reliability, and efficiency. It can be time efficiency and cost efficiency in the network, and to make the network more flexible and agile. With this, I'm going to conclude today's lecture. I hope you got the basic idea about network function virtualization and how it is used in tandem with SDN, which is again, they are supportive or complement each other, but to different technology working in tandem to provide virtualization support to the network. So that's all for today. I hope to discuss more in detail when we meet face to face. Till then, goodbye.